Hello guys, a very warm welcome to my IT class. We are going through a series of C++ tutorials. In that one we are discussing C++ functions. So one of the important concept related to C++ function is a reference variable concept. This concept is exclusively available in C++. Normally it is used to create alias names for variables. So in the last video you have seen when a function modifies more than one variable, and if you intend to reflect those modified values back, then you need to pass addresses, as the limitation of return statement is that it can return only a single variable. But if you need to reflect more than one variable from function, then you must pass addresses. When you pass addresses, you must collect them in special containers variables called pointers. So you have seen how complex the structure is when we pass addresses using ampersand, that is address of operator, value at, that is a star. So the structure of the program will be little complex and the readability will not be that good. So for that, the alternative available in C++ is the best alternative, you can say. It is a reference variable. If we create an alias name for the past variable, the variable which we are passing, for that if we create an alias name, and if it gets modified over there, automatically it reflects back. How it does that? First we'll see with a simple example. We'll create alias name for one existing variable, and then how, if the alias name is modified, if the alias variable is modified, the original variable for which it is referring, that also gets modified. We'll understand this aspect now. Let's say here there is a main function declared a as a variable. It is an integer variable. Now I'll be creating an alias name for a. So what is the alias name? I need to use the syntax for it. So the syntax for it is like this. The data type we have to say, this is the syntax. Data type we have to mention, and this is the reference operator. Then you have to give alias name for it. So whatever name you would like to give, another name. So you have seen in our day-to-day life also, one person has alias name, many alias names. Say Vikas is a name, then we say Vicky also. So Vicky is alias name for Vikas. Anything it could be. If some name is there, Bunty is a alias name for some person. That way it means what, when we say alias, it is the same person. So for whom that is created, that is this var. So for this var, the alias name is created. Now here, this is the syntax used. Data type reference operator. Don't call it as address of, it is a reference operator. Then this is a alias name. So X is alias name here. You can say it is a alias name. A is a original existing variable. So you can create only alias names or reference variables for existing variables. If the variable is not there, you cannot create alias name. So this is a existing variable A. Now X is alias, so if X modified, A gets modified. If A is modified, X gets modified. So this is how now X is 7. So when we create, because of this statement, what happens? X will become a alias name here. So X will also point to the same variable. And when X is modified, say it is as good as A is modified. So when you display A and X, the output is 7 and 7. A is also 7, X is also 7. This concept I'll apply for what? For returning multiple values from a function. I pass some variables, and if they get modified, they should be reflected automatically. For this, I'll take the help of this example. Look at this example. Here I have two variables, A and B. So I'll be calling a swap function. You have seen if I am using address of variable concept, that is a pointer, you need to pass address of A, address of B, then you will be collecting them in pointers, and here value add you have to use, which is somewhat complex syntax you can say. Now the simple syntax and with more readability and understandability is passing a variable by a reference, that is creating a reference variable for it. So what I will do now here, I will pass A and B. I will not be passing address of A and address of B. I will be just passing A and B, you can say here. A and B I am passing. Okay, fine. When you pass A, for that you create alias name here in swap function. For B, again a alias name for swap function. So how the syntax would look like, the function definition would look like this. Int reference, say x is a reference for A now. Int reference y. So x is alias name for A and y is alias name for B. So if x gets modified, A gets modified. If y gets modified, it is B, like that. So because of this statement, this is actually how it is interpreted with compiler. It is interpreted like this. So you are creating a reference variable x, for which variable? The A, passed variable. So this is a passing. So when you pass, it is coming over here and it gets assigned to this statement. This is how the reference variable is created. So x is a alias name for A, y is alias name for B. So because of this statement, they both point to the same location. X points to A, y points to B. So here x and y get swapped. It means here they will be reflected automatically. They get swapped here in main function. That will be reflected in main. This is how the syntax will be more simple compared to pointer syntax. Say with pointer you would have said value add and address. So that way it is little complex. We try to avoid whenever we have an alternative of using reference variables. We avoid pointer. Where pointer is inevitable, there you can use pointer only. So there are some situations where pointer is must. So let's see more about reference variables. This is the one limitation you can say. Once a reference is created, it cannot be later made to refer another object. Now I'll demonstrate you here. Say if this is a variable int reference x. So x is alias name for A. X is alias name for A. Now same x you cannot use for later on. You cannot change for another variable. This way it cannot refer to, later it cannot be made to refer to another variable. But with pointer this is not the case. With pointer what happens here, say if you have a int star p, this is the difference between pointer and reference variable. Say you have said address of A, in p you are storing address of A. After some time later in the program you may change the address in p to address of B. This is allowed. So this is the main difference of pointer and reference. So in cases where such one single pointer can keep taking different addresses, if such is the requirement, their pointers are best option for you. Reference operator will fail there. So then another thing is references cannot be null. We must have some existing variable for it. Then only we can create a reference. Say x, I cannot say x is a reference to null. Nothing. Not like this. It's not possible. We must have a variable existing like A or any variable. It must be created in the beginning before this alias name you are creating. This is the difference. But with pointer it is not so. You can create a pointer p in which you can store null. It can point to null. null address, means nothing is there, we have cleared the value. This is the second difference. A reference must be initialized when declared. Like now say pointer is there, you are not initializing, you are declaring p but you are not initializing. Later after some time in the program you may initialize, say address of a, like this. But with reference it is not the case. When you are creating a reference like reference alias name x, you cannot leave like this and then I'll say x is a. No, this syntax is not allowed. It must be initialized at the time of declaration. So you are declaring here, you are creating alias name. Here itself you must mention for which variable you are creating a alias name. So this is how the reference variables differ with pointers. So now it is left to you. You have to do trade-off, like what is the situation, whether the program circumstances or conditions demand pointers, the use of pointer would be more flexible, or the use of reference will be more efficient. That you have to check depending on your requirement, and then you have to use. Now let's have some brainstorming sort of thing for you guys. I have here, you think and get back to me. Is it possible to return a reference from a function? Say you have defined a function like the one we have defined here. You have defined here a function now. So x is a reference, y is a reference. Is it possible to return x back to the calling function? Is it allowed? Since x is a reference to a, and if there is a need sometime, say you want to return, is it possible to return? Just check out that, you think over it. Then can we create a reference to another pointer? So you have already one pointer variable. For that, can you create a reference? Like this is the case. Let's say int star p and int a is equal to 5. Then what you will be doing, in p you are storing address of a. Fine. In p you are storing address of a. Can you create a reference? Now I am creating a reference here, alias name, say q, for p. That is the meaning. Can we create a reference to another pointer? P is a pointer, no? Can we create a reference? Pointer is also a reference which we need to dereference, but reference variable is one which gets dereferenced automatically. This is the difference between again a pointer and reference variable. A pointer we must dereference using value at address operator, that is star asterisk, whereas q we don't need to dereference, automatically it gets dereferenced whenever it is referred in the program. So this is the thing. Can we create a reference to another pointer? You just check, is it possible? This is another question for you for thinking. Then a reference always refers to a legitimate value. State true or false. Yeah, this thing I told you, just we should have something existing variable, then only we can create a reference variable. If it's not a legitimate value, so you are referring to a variable which is no more in the memory, which is destroyed in the memory, and in that case, so whether we can do, just check with the syntax and language. So with this I'll conclude the session on reference variables. So the takeaways of this session are: a reference variable is a best alternative for pointers. If possible to avoid pointers and can use reference variable, you can do so. If pointers are inevitable, then you can avoid reference variable and use pointers. Second, whenever multiple things you want to reflect from function, there also you can use a reference variable. You can create a reference variable for any user defined data type also, like classes. You can create reference variable for objects also. That is the meaning. So with this we'll conclude here, and we'll conclude function concept totally altogether. In the next video we'll start a new chapter, classes and objects. How to define a class, how to create an object, we'll start. So till then, take care And if you enjoyed the session, just share it with your friends. Thanks for watching. Take care. Bye.